This video will be on ions from chapter 7.1. Be able to define valence electrons, the electron dot structures, the octet rule, a cation, and an anion. We will define each of these in the lecture. Be able to relate electron dot structures and valence electrons to the energy levels, which will send you back to chapter 5.1. And use the periodic table as a model to predict the relative properties of elements based on the patterns of electrons in their outermost energy level of atoms. Valence electrons are those electrons in the outermost shell of an atom. So think about the highest occupied energy level, basically what is on the outside, because the electrons on the outside are going to be the ones that are going to be interacting with other things, indeed other atoms. Take some moment to remember energy level and remember the various orbitals, because we will be getting back to that. If you want to go watch the video on 5.1, that might be a wise idea right now, because you will remember that this has something to do with periodicity. As we look at the alkali metals in group 1, they have one valence electron. The alkali earth metals in group 2 have two valence electrons. The transition metals will have between 3 and 12 valence electrons, and you can tell that is going to get a bit more complicated, just like the intertransition metals here at the bottom of the periodic table will have between 3 and 16, which will get even more complicated, especially when it comes to separating these in compounds. You see group 13 over there with boron is going to have 3 valence electrons, and then you have group 14 will have 4. Then we move on to nitrogen with 5, oxygen with 6, and then the halogens are going to have 7. And here we have the noble gases with either 8 or 2, and that is going to mean they have an unfilled outermost energy level. We draw these as electron dot structures. So instead of trying to remember how many shells each thing has and how many valence electron each thing has, we just draw a little dot. So electron dot structures, or Lewis structures, are diagrams where each electron in the valence shell is shown as a dot. Here we have hydrogen with 1 dot, calcium with 2 dots. That means they have 1 and 2, respectively, valence electrons. Over there we have argon with a total of 8 dots, and you can probably guess this only really goes up to 8, which is why these transition metals are going to get much more complicated later on. And going up to 8 means we have something called the octet rule. The atoms will have 8 electrons in their top energy level. Please take a moment to remember the Aufbau principle that the s and p orbitals fill first. This means your s orbital with 2 and your p orbital with 6 will add up to 8 electrons in the outermost energy shell. That's the kind of the goal of how much to fill it with. Basically, 8 is enough. And we can do this multiple ways. First off is to lose an electron and then come down to 8. And this is what happens with cations, which are positively charged ions. Metals and metalloids form cations. So something like the alkali earth metals and the alkali metals will easily form cations by losing 1 electron from their valence shell. Sodium, if we look back up here at the periodic table, is element number 11. If it loses 1 electron, it has 10 electrons then, and that's going to mean 8 in its outermost shell and 2 in an inner shell, making it very much like neon. Calcium will have to lose 2 electrons to look more like, what is it? That would be calcium will look more like argon if it loses 2 electrons. Now, things in the inner transition elements, those might be a little more complicated in order to get all the way back to their noble gas state, which is why they are a bit more difficult to deal with, and they can often form multiple types of cations, being like iron 2 and iron 3, and we're going to look at that in later lectures. Anions, on the other hand, are negatively charged to the gain of 1 electron. Chlorine will gain 1 valence electron to become a chloride anion with a negative charge of -1. Oxygen will gain 2 electrons to become oxide ion with a negative charge of -2. We will definitely see the halide ions are halogens. The halogens, when they gain an electron, become halide because you add the IDE ending to an anion to denote that it has a negative charge. Another example, that oxygen will become oxide. So something like iron oxide is going to be a combination of an iron cation and an oxygen anion.